Hi guys, today we will just go through this lab, tr- troubleshooting and solving data join pitfalls. So I have just uploaded videos regarding these three labs as well. Please check it out, guys. It will be in my GCP data engineering playlist. Yep, let's just get into this lab session. So troubleshooting and solving data join pitfalls. Okay, so we'll just go through overview. BigQuery is Google's fully managed, no-ops, low-cost analytics database. With BigQuery, you can query terabytes and terabytes of data without having any infrastructure to manage or needing a database administrator. BigQuery uses SQL and can take advantage of pay-as-you-go model. BigQuery allows you to focus on analyzing data to find meaningful insights. Joining data tables can provide meaningful insight into your dataset. However, when you join your data, there are common pitfalls that could corrupt your results. This lab focuses on avoiding those pitfalls. Types of joins. Cross join combines each row of first dataset with each row of second dataset, where every combination is represented in the output. Inner join requires that key values exist in both tables for the records to appear in the results table. Records appear in the merge only if there are matches in both tables for the key values. Left join. Each row in the left table appears in the result, regardless of whether there are matches in the right table. Right join. The reverse of a left join. Each row in the right table appears in the results, regardless of whether there are matches in the left table. Okay, this is the dataset you will use is an e-commerce dataset that has millions of Google Analytics records for the Google merchandise store loaded into BigQuery. You have a copy of the dataset for this lab and will explore the available fields and row for insights. Okay, what you will do in this lab, you perform this task: use BigQuery to explore a dataset, troubleshoot duplicate rows in a dataset, create joins between data tables, understand each join type. Okay, so setup and requirement, guys. I have as I said, I have gone through this several times. It is just saying like click on the start lab and we will get our credentials to get into Google Cloud Console. Let's do that. Yep, I will just open this in incognito window. Yep, the username will be automatically filled in. I'll copy this password and try to paste this. Okay, understand. Yep, now we have logged into Google Cloud Console. Let's check this. Yeah, open the BigQuery console in the Google Cloud Console. Select navigation menu. Okay, so this you can do in the navigation panel, which is in the left, or else you can just type down here in the search bar. So just type down here BigQuery. So now it will automatically open the BigQuery console. Yep. Now let's see what task we have to do. So create a new dataset to store your tables. In your BigQuery project, create a new dataset titled e-commerce. Let's copy this. Click the three dots next to your Quick Labs project ID and select create dataset. The create dataset dialog opens. Okay, yep, we'll do that, guys, now. So here I have to click on this create dataset. Paste this is the name. I have to put all the default values. Then the dataset has been created. Let's check. Okay, the left panel you can see e-commerce table listed under your. Okay, I think it's the dataset. I'm not sure why they are calling the table. Okay, let's check the progress. Yep, we have created a new dataset. Now pin the lab project in BigQuery. Scenario: your team provides you with a new dataset on the inventory stock levels for each of your products for sale on your e-commerce website. You want to become familiar with the products on the website and the fields you could use to potentially join onto other datasets. Let me just go through this again. I got confused. Okay, So your team provides you with a new data set on inventory stock levels for each of your products for sale on your e-commerce website. You want to become familiar with the products on the website and the fields you could use to potentially join on to other datasets. Okay. The project with the new dataset is data to insights. So click the navigation menu, BigQuery. Okay, click done. BigQuery public datasets are not displayed by default in BigQuery Web UI. To open the public datasets project, copy data to insights. Okay, let's copy this. Add data, pin a project and enter project name. Okay, let's do it, guys. Where exactly is this? Okay. Yeah, here, add data, sorry. Enter project name. Let me just check. Add data, project name. Yes. To open the public project, copy datasets. Okay, let's do that. Pin, okay. Yep. So the data to insights project is listed in the explore section. Yes, in the explore section, as you can see, the project is been pinned. Okay, has been pinned. Now examine the fields. Next, get familiar with the products and fields on the website you can use to create queries to analyze the dataset. In the left pane in the resource section, navigate to data to insights project e-commerce and all underscore section. Okay, now on the right under the query editor, click the schema tab to see the fields and information about each field. Okay, let's do that. So here in e-commerce, all sessions raw. Let me confirm. Yep, this is the table. So schema, yep, I have clicked on the schema to see the fields and information about each field. Okay, so these are the field names. Okay, oh sorry, yeah, these are the field names and these are the types. Oh, in e-commerce this is all sessions raw. Okay, full, it contains full visitor ID, channel grouping, time, country, date, visitor type. Okay, product information, product name, categories, item quantity, currency code, search keyword, e-commerce action type. Okay, so we have done that. Now identify a key field in your e-commerce dataset. Examine the products and fields further. You want to become familiar with the products on the website and the fields you could use to potentially join on to other datasets. Let's check that. The main thing would be, I mean, product ID or SKU, or that's the thing, right? So I'm not sure, like, and the transaction ID, yeah, let's see, check that. Examine the records. In this section, you find how many product names and product SKUs are on your website and whether either one of those fields is unique. Find how many product names and product SKUs are on the website. Copy and paste. Okay, let's check. What we are finding here, like, how many product names and product SKUs are on the website. Okay, so basically the distinct values. So we will click on this compose new query. We'll paste this thing. This query looks good. Okay, I just run this. Okay, these are the unique product SKU and the product name. Let's see how many. There are a lot of products. Yeah, click run. Now look at the pagination results in the console for the total number of records returned. Let's see. Yep, 2273. Yep. How many rows of product data are returned? 2273. Yep. But do the results mean that there are that many unique product SKUs? One of the first queries you will run as a data analyst is looking at the uniqueness of your data values. Clear the previous query and run the below query to list the number of distinct SKUs are listed using distinct. Let's check that. So we will just remove this query, update this query with this new, and I will run this. Let's see, I can see only 1909. How many distinct SKUs are written? 1909. Yeah, we have fewer distinct SKUs than the SKU and product name query I had written before. Why do you think that is? Our first query was excluding some product names. Our first query showed that only one product name can belong to an SKU. Our first query also written product name. It appears multiple product names can have the same. Yep, I guess this because SKUs are distinct, but product names could be, yeah, multiple. Yeah. Now examine a relationship between SKU and name. Let's determine which products have more than one SKU, okay, and which SKUs have more than one product name. Both looks the same. Let me just reread it. Let's determine which products have more than one SKU. Okay. Okay. Yeah. I mean, multiple products can have I mean, more than one SKU. Yep. And which SKUs have multiple? Yep. Got it. So clear the previous query and run the below query to determine if some product names have more than one SKU. Notice we use the string aggregate function to aggregate all the product SKUs that are associated with one product name into comma separated values. Let's copy this. Right, okay. I will just okay, this, paste this, and I will run this. Okay, what does it infer? Let us check. Yeah, so it is just for each product name, it is giving me the SKU count, like how many SKUs it is related, and these are the values. Okay, sorry, I think each product, suppose Google sunglasses, it might contain 10 SKU, and this particular SKU, this is related to this Google sunglasses. Okay, interesting. Yep, let's check. Okay, click learn. Okay, we got this. So these are the questions. Okay, do some product names have more than one SKU? Look at the query results to confirm. Do some product names have more than one SKU? Yes, as you can see, there are more than one SKU, right? Yes, I can say yes. Which product has most SKUs associated? Most SKUs. So, oh, let me check. This is 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. Here's the first one, like 1, 2, 3, 4, 5. Most SKUs. Oh, sorry. Yeah, this is the SKU count, right? Sorry. Yeah, I think this would be, yeah. Yep. You can see on the e-commerce website catalog that each product name may have multiple options, size, color, which are sold as separate SKUs. So we have seen that one product can have, yeah, 12 SKUs. Or what about one SKU? Should be allowed to belong to more than one product? So clear the previous query and run the below query to find out. Okay, let's just clear this thing and click on run. Okay, what does it infer for each product SKU? Product count, and these are the product names. Okay. Okay, note try replacing string aggregate with array aggregate instead. Pretty cool, right? Let me just check. Okay, Array aggregate, okay. Let's check. Okay. Wow. I mean, it's the product names are in different rows. Superb. So when you look at the query results, are there single SKU values with more than one product name associated? What do you notice about those product names? So single, okay. Wait, do I check? Okay. No, the product SKUs match the product names one for one. No, as most of the product names are similar but not exactly the same. Oh, let me understand this. When you look at the query results, are there a single SKU values with more than one product name associated? What do you notice about those product names? Okay, these are different. As most of the product names are similar but not exactly the same. So two, yeah. If I say two, yeah, this is two. Yeah, I guess this. Yep. So you will see why this many to many data relationship will be an issue in the next section. Okay, let's check. So we have identified a key field. Okay, now this is done. So this is the pitfall, non-unique key. In inventory tracking, a SKU is designed to uniquely identify one and only one product. I'm not sure what I forgot the SKU full form. Okay, stock keeping unit. Superb. So in inventory tracking, a SKU is designed to uniquely identify one and only one product. For us, it will be the basis of your join condition when you look up information from other tables. Having a non-unique key can cause serious data issues, as you will see. Oh, let me just read it. Sorry. In inventory tracking, a SKU is designed to uniquely identify one and only one product. For us, it will be the basis of your join condition when you look up information from other tables. Having a non-unique key can cause serious data issues, as you will see. Okay, write a query to identify all the product names for the SKU. Okay, possible solution. Let's check this out. Clear this query, paste this thing, click on run. Let's check. So for this product SKU, we have different product names as well. Okay, interesting. So click run. Yeah, we have done. So what do you notice about the product names? They are mostly the same except for a few characters. Yes. From the query results, it looks like there are three different names for the same product. In this example, there is a special character in one name and a special different name for the other. Joining website data against your product inventory list. Let's see the impact of joining on a dataset with multiple products for a single SKU. Stock keeping unit. First, explore the product inventory data set, the product tables to see if this SKU is unique there. Clear the previous query. Okay, let's do it, guys. Yeah. So it is getting the fields SKU name, stock level from the specific e-commerce. Okay, where SKU is this? Okay, here stock level 154. Let's check. Is the SKU unique in the product inventory dataset? Oh, product inventory dataset. Yeah, this is a products table, and I got only one record, so I can just say one. Yep. How many dog frisbees do you have in inventory? 154. So now, what is this? Join Pitfall. Unintentional many to one stock keeping unit relationship. We now have two data sets, one for inventory stock level and other for our website analytics. Let's join the inventory dataset against your website product names and SKUs, so you can have the inventory stock level associated with each product for sale on the website. Clear the previous query and run the below query. Cool. So in other videos, guys, I will just try to explore these queries as well, but as of now I'm just following the I really don't, I mean, I will dig deeper into these all queries as well, but as of now we have a limited time and this task need to be done, right? So yep. Click on run. Let's see. Okay, we got product name, product SKU and stock level. Oh. What happens when you join the website table and the product inventory table on SKU? Do you now have the inventory stock levels for the product? Inventory stock levels for the product, yes, I do have, but it's a multiple. Yeah, yes, we have inventory stock levels, but stock level is showing 3 times, one for each record. No, we don't have inventory data. The join did not work. Yes, we have inventory data and everything looks fine. Yes, I think this is first one. Yep. Next, let's expand our previous query to simply sum the inventory available by product. Clear the previous query and run the oh, clear the previous query and run the below query. Okay, let's do this. Okay, let's check. Now click on run. Now what did we get? Total inventory 462 for this single SKU value. Okay. Is the dog frisbee properly showing a stock level of 154? No, because I think it is 462. I think it is combining three. Yeah, it is, yep, triple counting on the inventory. This is called unintentional cross join. A topic will, okay, cool. Let's check our progress, guys. This is done. Good. Now join pitfall solution. Use a distinct SKUs before joining. Okay. What are the options to solve your triple counting dilemma? First, you need to only select distinct SKUs from the website before joining on other datasets. We know that there can be more than one product name, like that can be shared as a single SKU. Let's gather all the possible names into an array. Let's see. Okay, we have arranged them, all the different names of a single product SKU. Now instead of having a row for every product name, we only have a row for each unique SKU. If you wanted to deduplicate the product names, you could even limit the array like so. Okay, let's do this. Okay, I think it's okay. Deduplicate. I mean, having only one value. Okay. Join but for losing data records after a join. Now you are ready to join against your product inventory dataset again. Clear the previous query and run the below query. Okay. Okay, now we got, yeah, 1090 product SKUs. Yep. How many records were written? All 1901 distinct SKUs? No. It seems we lost 819 SKUs after joining the datasets. Let's investigate by adding more specificity in your fields, one SKU column from each dataset. Clear the previous query and run the below query. Okay, this is the website, the data which we have, I guess, SKU. 1090. Yep. It appears the SKUs are present in both of these dataset after the join for these 1090 records. How can we find the missing records? Join pitfall solution. Selecting the correct join type and filtering for null. The default join type is an inner join which returns records only if there is a SKU match on both the left and right tables that are joined. Rewrite the previous query to use a different join type to include all the records from the website, regardless of whether there is a match on a product inventory SKU join type options. Inner join, left join, right join, full join, cross join. So they are using a left join because from all sessions raw they needed the data which are not matching, and the right part is e-commerce products. So let's see, let's check this query, guys. Click on run. Yep, 1909. I can see there is a null value. Yep, you have successfully used a left join to return all the original 1909 website SKUs in your results. Purpose many inventory SKU values are null. Inventory, yes. How many SKUs are missing from your product inventory set? Write a query to filter on null values from the inventory table. Yep. Click on run. Yep. So I can see there are 819 which are having inventory value as null for SKUs. How many products are missing? Yep, 819 products are missing. SKU is null from your product inventory dataset. Clear the previous query and run the below query to confirm using one of the specific SKUs from the website dataset. What is this? Sorry. Clear the previous query and run the below query to confirm using one of the specific SKUs from the website dataset. Okay. It is selecting from this product inventory and okay. So there is no data to display. So why might the product inventory dataset be missing SKUs? Some SKUs could be digital products that you do not store in warehouse inventory. Old products you sold in past website orders are no longer offered in current inventory. There is a legitimate missing data from inventory and should be tracked. I think oh wait, I think this sorry. This might be the one. Yep. Okay. So now what about the reverse situation? Are there any products in the product inventory dataset but missing from the website? So write a query using a different join type to investigate. Let's do this. Yep. Let's see the results. Yep. Wow, interesting. So it is having an inventory SKU but a website showing as a null. Answer yes. There are two product SKUs missing from the website dataset. Next, add more fields from product inventory data set for more details. Clear the previous query and run the below query. Okay, website SKUs are null for these SKU values. Name, ordered. Okay, sentiments. Okay. So why would the below products be missing from the e-commerce website dataset? So possible answers: one new product, no new product, yeah, no orders, no sentiment score, and one product that is in store only. Okay, in store only. Okay, got it. Another is a product of zero orders. Okay, why would the new product not show up on your website dataset? The website dataset is past order transactions by customers brand new products which have never been sold and won't show up in web analytics until they are viewed or purchased. You typically will not see right joins in production queries. You would simply just do a left join and switching the order of the tables. Interesting. What if you wanted one query that listed all products missing from either the website or inventory. Write a query using a different join type. Possible solutions. Select distinct. Okay, let's do this. What is what if you wanted one query that listed all products missing from either the website or inventory? Okay, basically, or let's check this out. Results. Okay, so website SKUs. Okay, click run. So now I can see there are, yeah, 821. So 819 plus 2, yeah, 821 product SKUs. Left join plus right join is called full join, which returns all the records from both tables regardless of matching join keys. You then filter out where you have mismatches on either side. Full join. So I've used full join on the website data and product inventory. So join pitfall, unintentional cross join. Not knowing the relationship between data tables keys like one to one, one to many, many to many can return unexpected results and also significantly reduce the query performance. The last join type is a cross join. Create a new table with a site-wide discount percent that you want applied across products in the clearance category. Clear the previous query and run the below query. So here we are, I think, creating a table. Let's just copy this query, remove this the previous, then create or replace table e-commerce. So here site-wide promotion, this is the table which we are doing, and yes, yep. So this statement has created a new table named site underscore wide underscore promotion. Cancel. Okay, well. So in the left panel, site underscore wide is now listed in the resource section under your project, and yes, let me check. Yep, yes, it has been done. Yep. Clear the previous query and run the below query to find out how many products are in the clearance. How many? Okay, these are so 82, 82, right? So how many percent? Yep, 82. Note, for a cross join, you will notice there is no join condition. Example, on or using. The field is simply multiplied against first data set or 0.05. Okay, on or using. Let's just check. Oh yeah, for cross join, we didn't use any on condition because it will just do for each data set in left table, it will associate with all the records in the right table. Yep. Clear the previous query and run the below query to insert two more records into promotion table. Insert into billing has not been enabled for this project. Sorry, I don't know what's happening with this. Oh, okay. DML queries are not allowed in. Data manipulation language queries. Okay. I'm not sure why. This is, so this has to be. Yeah. I don't know. I don't think so. They have enabled for this query. Okay. Let's just do the select clear previous query and the below query. Okay. I guess we won't get this because only one, because the insert is not working, guys. So it might be, yeah. How many? Because it might be the answer 3. Okay. So what happens when you apply the discount again all the additive clearance products? Clear the previous query and then below query. I think it got messed up because the insert query is not working as mentioned in the task. Let's see how it goes. So as of now I still have 82. No, yeah, but because insert is not working, so we can't check this. Okay, let's investigate the underlying cause for examining one product SKU. Clear the previous query and run the below query. Okay, now we can't do that because The table is not updated because of the insert query. Let's see what are the impact of answer. Since there are 3 discount codes to cross join, you are multiplying the original data set by 3. This behavior isn't limited to cross joins. With a normal join, you can unintentionally cross join when the data relationships are many to many. This can easily result in returning millions or even billions of records unintentionally. The solution is to know your data relationships before you join and don't assume keys are unique. Recall that apply. What are the pitfalls of joining data? Unintentional cross join, yes. Permanently missing data that have been included, or counting some data more than once. Permanently deleting the data set, no. Missing data that can be included, yes. Yep. A full join returns what? Records only in both tables. Records from one table minus the records, no. All the records from both the tables. Records that are not, wait, one more choice. Records that are no, all records from this, yeah. No, full join has to be records only in both tables. All the records, no. Wait, wait, what happened? Yeah, records only in both tables. Full join basically, yeah, it will do on a specific condition. So it returns records only in both tables, or records from one table minus the other tables. All the records, no. What? No, something's happened. Records that are not in both tables, records from the tables. I don't know what to answer. As far as I know, the full join like returns basically right join plus okay, all the records from both tables. That is, yep. Sorry, yeah. Full join is nothing but left join plus right join, right? So yep. Check my progress. Join pitfall solution. We have executed these queries, but the insert is not working, guys, here, because let's do this again. So billing has not been enable billing yet. Let's check this. So DML are not allowed in Freighter. Set up a billing to remove this extraction. Okay, let's do that. Okay, billing. Let's check. Oh no, it's not working, guys. So it won't work for this. I mean, this task won't be completed. Yep, it won't work. Let's check. I mean, let's check this query as well, but yep, it doesn't work, I guess. Yeah. Wow, interesting. Yep. So I think we have completed this, guys. So let's check the progress. Failed to observe. Okay. Yep. This has been done. Okay. Now let's go what we have done in this entire session. So we basically we have done troubleshooting and solve some data join pitfalls. We've gone through this overview of BigQuery service. Then this is just a setup, and we have created a data set to store the tables. Then we have pinned a public project, and we are using e-commerce data from that. We have examined the fields, of this public project, and this is public table, sorry, the data set, and all sessions raw is the table. So we have identified a key field for products. I mean, there is a SKU, that is a stock keeping unit, that we have identified. So there are products, these many products. We have analyzed the data, then clear the previous query. Okay, this is we have done. We have examined the relationship between SKU and the name, product name. Then what else? Yeah, these are the pitfalls and how non-unique key pitfall, and we have joined the website data against our product inventory list. Unintentional many to one SKU relationship. So these are all the joint pitfalls, guys. So which we have avoided by using right kind of joins on these tables. And join pitfall solution, use distinct SKUs before joining. Okay. Then what else? Let's check. I think that's it, guys. We have yeah, this is unintentional cross join. That's it. Yep. So thanks for watching, guys. Let me end this lab. Okay. Let us check the path again. Yeah. So here we have completed 4 labs. This lab is not completed because one of the task is not working fine. I mean, it's not evaluating, but we have completed. I have also posted the lab of this specific thing as well in the YouTube. Check this out, guys. So we still have 2 more labs, and this is a challenge lab. Let's. I hope I will just upload these as well. Yep. Thanks, guys. Thanks for watching.